These are the final results of our models LLM evaluations. I will go with Grok 4.5 model because it is giving 90% accuracy. Here you can see the detailed LLM evaluation. By the end of this project, you will get to know how you can reduce the cost of your AI application by 50% to 90%. So let's go deep dive into it. Hello everyone, my name is Vivek Pod and welcome back to my YouTube channel Better Call Paul. So in today's video, we are going to learn about LLM evaluation. Why to learn LLM evaluation? What is it? When to use? Where to use? Why to use? Everything. So all the concepts we will clear first of all. In the first part of the video, we will cover the theoretical parts, and in the second part, we will cover the practical part. All the source code I will explain you in detail. So what is the LLM evaluation? See, everyone is now building AI application, but no one is monitoring the cost of AI application. If Claude $20 per month, Claude is doing all the tasks, then why should someone buy your $1,000 per month AI application, which is giving low accuracy and which has a high latency, then why anyone should buy your $1,000 per month AI application? He will go with a Claude $20 per month application subscription. So this is the major challenge, and that's why many of the AI startups are failing because they are not able to monetize. They are not able to control the cost of AI application. In this video, we are going to discuss like how to choose a particular LLM model. Like if we see YouTube videos and we see reels like uh, every week new model launches. Like before, means today is the 22 August 2026, and see right now Fable Max is very powerful and it is like everyone knows that this is very powerful model and it gives highest accuracy. So it is not necessary that you should integrate a Fable model into your AI application. It is very costly. No matter means it is very accurate. I am agree with it, but the cost is very high, and you will fail in the market if you integrate your Fable Max to your AI application and you launch your product. So and developer directly say like use Fable because it gives good accuracy and our application will be highly accurate. But that is not the proper case study. If you if you try and test all the LLM models with your AI application, then you will get to know like okay, this model is also good for our AI application. So how normally you can try and test different LLM models? Of course, you will change the models in your .env file. A lot of things your model is connected in your source code, so everywhere you will go and change your model like from Fable to DeepSeek to reduce the cost and check the accuracy again and again, then from DeepSeek to GPT-4o mini. So every time you change the entire source code and every time you will run the application and check the accuracy and all, but that is not the proper direction. Means this takes a lot of time. Means changing the code takes a lot of time. After that, testing the entire code, testing the entire application takes a lot of time. So this is not a proper direction. So what is a good approach? Like many developers, many scientists develop some libraries. Like one is Deep Eval and another is Ragas. So with the help of these tools, you can evaluate which model to use, and it also depends on your use case. Means what is your particular use case? So, for example, let's say your use case is just rewriting the query. Then, for that task, a very simple LLM model is required. It is not like Fable is required. For example, I type some I have some typo error in my user query. A lot of spelling mistakes are there. A lot of abbreviations are there in my query. For example, what is the FCF of Infosys in 2024? So FCF is short form, right? It is abbreviation. What is the full form? Free cash flow. But I write down only what is the FCF of Infosys. But I need to again modify my query. So for that, I have to use one LLM model, right? Which will give us detailed query. What is the free cash flow of Infosys? And that generated detailed query will be sent to next step of our advanced RAG system, right? So this is a simple query. So it is not necessary means it is not necessary to use a heavy model, FableMax, and it is also not necessary to use very cheap model, for example, DeepSeek or any other. We have to do some optimization. We have to select a particular model. So what is the best technique to select that particular model, and that technique will have a very low cost as well as we can test it in very short time. So our project is right now based on this thesis. We will we will test all the LLM models within very short time, and we will decide for this specific purpose. We will go with this LLM model. Okay, so this is a short introduction, means what we are going to solve the problem, market problem right now. Now I will show you some interesting example. I will switch to another screen. Now I just search what is the net profit per year of Cricinfo company, or that this company has their website Cricinfo. Okay, everyone knows about it. So I just searched it, and I got some information like what is the annual revenue of Cricinfo. So they say that 15 million to 25 million dollars every year they earn, and they earn through digital advertisements and display banners. Means for example, by showing the advertisements on their website, they earn money. So how they can increase their revenue more if they are able to retain the end customers for longer time on their website, then the customers will see the advertisements more time, and this is how the website will earn more money, right? So that is means retention is very important to increase this profit. Okay, so 15 million means how much? I will show you. 15, 1, 2, 3, 4, 5, 6 multiplied by 95.7 is the dollar rate. I will show you. Okay, this is the dollar rate. Okay, so how much it is? 143 crores 55 lakh rupees is the per month. Means this is 15 million, and if I 6 multiplied by 95.7, so 239 means 250 crores they are earning every year. Okay. Now, if and of course because of AI, why this much they are earning? Because they have integrated some AI chatbot in their website. Before that, this 250 crores means less than 250 crores was their profit. So I will show you their chatbot. See, you can see here. This is their chatbot they have built. If I write down something like what is the highest score for Indian something and hit enter, then you can see they give the result. And now you know, means a lot of people are big fan of cricket game in India. So they just retain, means they will stay on this website. So the end user will stay on this website because of this chatbot feature. Previously, end user stay because this website gives every ball delivery scores, like okay, 6 balls is 1 hour. So for first ball, who how many runs are there? Is there any 6 or 4, or is there any wicket? So every time user just reload. That is simple, and simple thing present in this website, and this is advertisement they show. Okay, this is some company's gaming website, play with cricket based game something. This game advertisement they show. Okay, GoDaddy, this is another advertisement they show, and uh, because of this this Creek Info is earning how much money? This much money, 250 crores, 239 crore rupees they are earning. And after that, to increase this revenue, they integrated this chatbot. So those who are very much interested in cricket, they just write down query, and They get this information. Okay, Seva score 319 run, 319 run, then 303 runs, KK Nair. So this kind of information they get. How with the help of this, the retention of the end users increased on this website, and because of these advertisements, companies started earning this much money. Now, how this thing happened? See, this is a very natural English language. These get converted to SQL query. That SQL with the help of LLM. That SQL query goes to the SQL database. Hit to the SQL database. SQL database then returns the output, and this output again go to the LLM, and LLM then again refer the question and the output generated by the SQL database, and return answer in natural English language. So this is like NL to SQL functionality. Okay. Now, how much should be the cost? Okay, for this new feature, new chatbot. For example, I will tell you this 239 divided by 12 month. Okay, so 19 crore rupees means 20 crore rupees is the per month net profit of this website. So 20 crore rupees they are paying. How much they want to invest in this? So let's take an example like they want to spend 3 lakh rupees a month for this NL to SQL feature. Okay, and let's say they miss crores of end users are continuously watching this Cricket Info website. And for example, 50,000 queries per month are hitting this NL to SQL feature. Means 50,000 queries simply means people just asking query, and the number of counts is the count of this natural language queries are 50,000. Okay. So which LLM model we will use? If we use FableMax, means I will show. Okay, okay, this is I will show you. So FableMax cost is like for input, it is costing $10 for input, $10 per million tokens, and $50 per million tokens is the output cost. Okay, output per million cost. Okay, but it is very heavy. I will show you the exact calculation as well. So this is a website benchlm.ai where you can see a lot of models means showing 25 out of 393. 393 are the models. So you have to find out the good model, as well as you have to consider the cost as well. Okay. Also latency you have to consider how much time is required. So I will show you. So this is the latency, yes. So latency, Mythos and Opus 5, it is a 52 second. Babel is very late, like it is slow, 122 second. Then GPT 5.6 Soul 209, and means after that you can see Quen 3.7 Max is 13.7 second. It is very fast, and the cost is not listed. You can see the cost MinMax 3. The cost is very low, $0.3 input cost, and output per million cost is $1.2. Means this is 50 times cheaper than Fable output per million cost. Okay, Fables is $50 and MinMax is $1 only. Okay, and also input cost is $10 versus MinMax is $30. So and speed is very high. Okay, so how to check and also you can see here tokens per second means this is also speed calculator. FableMax is like 75 tokens per second. It is generating very slow. Then you can see use Spark 217 tokens per second. It is generating. Then this is Misha. This is fast versus slow. You can see Gemini 3.6 Flash. This is fast versus Kimi K3. Kimi K3 is slow. 41 tokens per second it is generating. So speed you have to consider. You have to consider the cost. You have to consider the accuracy also. Everything you have to consider. Now I will show you the token calculation. So this is the prompt we are going to send to the LLM. So this will be input tokens. Okay, from system prompt to the economy section. Okay. In this, we will include all the schema and the user question we are going to send to LLM. So this is the input token cost. This is the input tokens, and this is generated by application. This SQL query will be generated by the LLM model. Okay, and this then again go to the SQL database to get the answer. Okay, so this will be the output of LLM model. Okay, I will show you how. Just 1 second. Pen. Okay. Now I will show you with the help of this tab, pen tab. Okay. So first of all, our NLP query means a natural language programming. This natural language query will be sent to the LLM, and this LLM will give us the SQL query, structured query language. Means see, first of all, your English language goes to LLM. Then this LLM will convert this English language to SQL query language. This SQL query language goes to the SQL database, and this SQL database will give you the answer in some number format. Okay, number or text as output. Okay, and this again goes to the LLM. Now LLM will have your natural language as well as your SQL output. Okay, and after that you will get some output. And this again this will be your natural language programming. So this will be your simple English language output, where simple English text along with the number which is generated by the SQL database will be displayed on the website. Okay, now we will calculate the tokens. First of all, this how much input tokens, how much output tokens are there, so that we can further calculate the cost involved. Okay, so I will just select this. I hope, yeah, I can select this. Control C. So you can see tokencalculator.net is a website where you can calculate the tokens and how much tokens normally. So token calculation, you can see 100 tokens means 75 words. Okay, so that is the approximation. 100 tokens means 75 words, and this is words, not characters, not letters. Okay, this is the difference. But to avoid this confusion, you can use this website. I will just paste the input tokens, whatever we are going to send to the LLM. So here you can see 335 tokens are there and words 169 words are there. So roughly this SQL query can be bigger. So you should consider this as 400 tokens. Okay. Now I will again go to this OneNote. I will copy this output and I will again go here and paste. You can see output tokens are 98 tokens. Okay, and 58 words. So 98 tokens. So 400 is to 100 is our input to output token ratio. Okay, so I will write down here input tokens will be 400, output tokens will be 100. Okay, total tokens will be 500. Okay, now I will show you on the cost. But before that, you can see how the tokens are calculated. Like select B baller, these are separated, sum, total, extras. So this is how the token calculation works. So this is a interesting website. You can check it out. I will show you the costing now. Uh, okay, okay, here is the costing. So we will check with Fable first. Fable is more popular. $10 as input cost and $50 for output per million tokens. Okay, so I will go here and for Fable Max. So for per query, we will consider the cost, and after that we will multiply the cost with 50,000 queries. Okay, and multiply by 30 days. Okay, so per day, if 50,000 queries are hitting to the website, then what will be the cost? That is, we are going to discuss. So $10 per million. One, two, three, four, five, six. Okay, multiplied by how many input tokens? 400 tokens. Okay, plus $50 per million tokens multiplied by how many output tokens are there? 100 tokens. Okay, so which is equals to if you got this, then this with this. Okay, then this with this, then 2, then 2. 4 divided by 1000 plus 5 divided by 1000 means 9 divided by 1000, which is equals to 0.009 dollars per query. Okay, so you can of course calculate, 1 second, 95.7 rupees is equals to $1. Okay, 90. Okay, so you can calculate here also 0.009 multiplied by 95.7 is equals to how much rupees is this? 0.8613. 0.8613, which is nearly equals to 1 rupee. Okay, so this is a per query cost. Now this 0.009 multiplied by 50,000 queries, which is equals to 45 $450 uh, per month will be the cost. Okay. Means this is the rough figure. Like you can consider it as per day or per month, but I am going with per month costing. Okay, $450 per month. Or 1 second. Okay, this is a big website. Means a lot of fan followers are there. So I will just make this as per day costing. Okay, which is equals to 450 multiplied by 30 days. Um, 1 second. Okay, which is equals to 135.20. So this is the dollar per month cost. Okay. Now if you multiplied this with dollar rate 13500 multiplied by 95.7, which is equals to 12,91,950. 12 lakh is roughly it is 13 lakh. Okay. 13 lakh rupees per month. But our budget is 3 lakh rupees a month. Okay. Here I will write down budget is 3 lakh rupees a month. So the same I have calculated for others as well, but I want to calculate the cost of GLM 5.2 as well. I want to see uh, how I can integrate it. JLM 5.2. Okay. So here you can see the costing 1.4 to 4.4. Okay. 1.4 to 4.4. I will just make a quick calculation over here. 1.4 to 4.4. GLM 5.4. Input cost is 1.4, 1.4 per million, and output cost is 4.4, 4.4 per million tokens. Okay. So now I will again do the same calculation, that 1.4 per million multiplied by our 400 input tokens plus 4.4 output tokens, $4.4 per million tokens. This is million multiplied by our 100 is equals to how much? So this is the calculation I have done. So 0.00056 input plus 44, so which is nearly equals to $0.001 per query, which is equals to it is less than 1 rupee, means 5 paisa per query. I will write it down here, per query. And if we multiply by 50,000 query, then it is equals to 2,700 rupees per day. Okay. And if you want to calculate for month, then it is equals to 80,000 rupees per month. Okay. So this is GLM 5.2. Okay. So this is also famous model, which is equals to equivalent to Fable. Okay. Now I have similarly I have calculated the cost for other models as well. I will write it down. For Fable, our cost is 13 lakh rupees per month. For GLM 5.2, it is equals to 81,000 rupees a month. For GPT 5.6 Terra is equals to 4.47 lakh per month. For Kimi K3, this is also famous model. The cost is 4.83 lakh rupees per month. And for Grok, it is 2.5 lakh rupees a month. Then another model is Claude Sonnet. 5, it is equals to 2.84 lakh rupees a month. And another is MinMax. The cost is 42,009 means 42,000 rupees a month. Okay. Now we will check which model is good for our application. So this is out of budget Fable. We will not consider it. This we can consider, means this is near to 3 lakh rupees. Kimi GPT 5.6, then Grok, Claude Sonnet, JLM 5.2, MinMax. So these models we can consider. Now I will show you the source code. Before that, I want to show you. So this is the Kaggle dataset. I have downloaded this deliveries.csv file and matches.csv file. These big files I have downloaded. and the data is like IPL Cricket 2020 data, and it is from 2008 to 2024. But what I have did, I have cut this data from 2021 to 2024. Okay, so I will show you. So here you can see db.py. This file is used to build the SQL database. You can see this Kaggle database I have imported over here, deliveries.csv. You can see match ID, innings, batting team, bowling team. These columns are present over here also, deliveries.csv, match ID, innings, batting team, bowling team, over. Okay. So this is present in a CSV file, but our main goal is to convert NLP to SQL query. So we need a SQL database. So we will first convert this as CSV file to SQL database. Another file is matches.csv. You can see ID, season, city, date, match type, player of the month. So here you can see matches, ID, session, season, city, date, match type. So this exact data we have imported. Okay. Now let's go to this db.py file. So here is the source code. We are importing SQLite, pandas. You see in the requirement.txt, these are the important files. Pandas to read the CSV file, .env to read your .env file present in your local directory. Here your OpenRouter API key will be present. Then LangChain OpenRouter is library we will use. LangChain core we will use. So what is OpenRouter? I will show you OpenRouter. So here is the OpenRouter, means if you want to change the models, LLM model, then every time you don't have to change the source code, and you don't have to pay for all the LLM models. Means you don't have to create all the API keys and do separate billings. You can use only one OpenRouter API key. You can see here is my API key. Okay, and here is the pricing. This is my API key, OpenRouter API key, and $5. You have to pay $5 to get this API key. Free API key is also there, but very a lot of limitations are there. So it is better to give some money to this OpenRouter. And after that, you can see over here credits. Right now it is $4.08. I will show you how much it is costing us to test the application. Okay. So again, go back to this. This is my .env file. This is .gitignore. Means I will put all the source code in my GitHub repository, and we will avoid these .env PyCache files. So that's it. Now I will. You can see here SQLite 3 we have imported. This is to create the SQLite database. Then here you can see we are selecting only 4 years, 2021, 22, 23, 24. And in that database, means first of all, we will read it using pandas library, and we are converting this date to date frame, and if there are any errors, then we are avoiding it. And we are making the SQL database. You can see connect con.cursor. These SQL queries are there, and finally we are closing the connection, and printing date range, years, everything. So what I will do, I will just show you side by side. Here I will first of all write down CLS. Okay. Now I will run this db.py file by clicking over here, run Python file. Okay. I will run it. You can see the changes over here. Right now, no SQL database is there. I will click here, and here you can see IPL 2021-24.db is present. I will delete this, which I can show you again also. Delete this here, CLS, and just run this query. You can see database created IPL 21 to 24. Okay, so this match ID, inning, batting, bowling. So this database is created, and it is showing like uh, okay, match rows. Okay, two databases are created. First is matches row. You can see 279 rows are there. 280 because this is empty. I will scroll down. You can see 279 rows are there. 280 rows is empty. You can see these rows are created, and in deliveries database 67,303 rows are created. Here you can see these rows are created. Orphan deliveries should be zero, so it is zero. Date range is from 2021 to 24, and it is done, means this database is created. Okay, so now I will show you, means this database is created. Now we have to write down the SQL query. So I will go here. This is another .py file. Total 8 Python files we have. These four: db.py evaluator, then first stage, then golden dataset generator, make golden dataset, then OpenRouter slug.py, then schema extractor.py. So this is schema extractor means whatever the SQL database we are having right now. So we have to create a schema, and that schema we have to send to the LLM. Okay. So for this we have created this Python file. Extract the schema from IPL 2021 to 24 to SQLite DB database. Then print the exact table schema statements. Print the clean columns inventory and per table, and show three sample rows per table. This is the source code. Here, this is the name of a database. This is the okay. So this output, this file will be we are getting as an output schema underscore rename.sql. So these are a few functions like create statement, then save the schema, show the schema. Okay, then make rename copy, and SQL. You can see, so you don't have to know the entire source code. Just click on play button, run Python file. Here no SQL. What file? I will show you. Here no SQL schema rename file is present. Once I clicked it, you will say one file will be created. Okay, I have cleared. So schema.sql file is created right now. I will go here, and here you can see the schema of the table. In the matches table, these are the column names. ID will be integer, season will be text, text data type, ID, season, city, date, match type. Okay, ID, season, city, date, match type. So these are the column names of the schema. And another table is deliveries, where the columns are match ID will be integer, innings will be integer, batting team, bowling team, over, ball. You can see match ID, inning, batting team, bowling team, over, then ball, batter. Okay, so we have created this schema.sql. Now another thing is we have to generate a golden data set. What is golden data set? Is that uh, this is the database where there are columns like first is your natural language questions, and another column is your SQL queries. Okay, so you will run this natural language your SQL queries to your, you will hit this SQL queries to your SQL database, and see whether the answers is generating or not. If it is generating, then these are a genuine golden data set. Now this is the schema SQL. Now I will show you this make golden dataset.py file. So this Python file, what is the aim to build this file is we are creating a golden data set over here. This is a golden dataset generator file where we have write down. I have write down the 20 questions. You can see. I will make it as word wrap. So this is first question. What is the average number of runs scored per match? Total runs across all deliveries divided by number of matches. Give a single number. Okay. So this is the question, user question in natural language, and this is the SQL query. You can see select some total runs from deliveries 1.0 divided by select count all from matches as average runs per match. So this is the SQL query generated by this LLM. Okay, means this user query goes to the LLM. LLM converts this natural language to SQL query. So this is one. This is second question, third question. Like that, I have generated 20 questions data. Okay. Now I will run this code. You can see no file is there. I will simply run this code. First of all, I will write down CLS to clean this. I will run this. So I will check whether every SQL query is doing fine or not. Means every SQL query is working fine or not. This SQL query goes to this SQLite database, and if it is correct, then fine. If it is not correct, then it will show the error. So 20 out of 20 SQL queries are perfect, and hard queries are 8, brutal queries are 12. How this hard versus brutal, you can see diff is equals to brutal and diff is equals to hard. You will see somewhere. Yes, here. So hard queries will be 8 and brutal queries will be 12. So all the queries successfully pass. Means now because they are working fine, they are able to generate the answer, they are correct, they are generated by the analyst. We are going to put that into dataset dot csv file. Okay, make golden dataset.py. So this is how you will make a CSV file where you provide the ID, then difficulty, then question, gold SQL, then gold result. So if you run this query, I will show you the SQL, the golden hard CSV will be generated. Okay. So this file will be generated. How this file looks, you can see ID, difficulty, then question, then golden SQL, then gold result JSON. So this CSV data is generated. Okay, golden data set is generated. After that, this first test.py. So I have put my OpenRouter key inside this .env file. I have spent $5 on it, and I will just check whether it is working fine or not. Okay, so this is a random model like OpenAI GPT-4o, Open Routers model, and I'm importing my API key from this .env file. These are LangChain libraries I am importing. Okay, so this is the user prompt, user message, and model, then temperature, max tokens, limit, everything here. And question is equals to question, raw question. So I'm just checking whether my OpenRouter API key is working or not. Okay, I will run this query. You can see right now. I will just first clean this. Then I will run this first stage.py file, check whether it is working fine or not. Now it is working fine. So who scored most run in 2024? Okay, who scored most runs in 2024? This is the question, and this is the SQL query. Okay, so the LLM is able to generate the SQL query. So it means our flow is working well. After that, means we have check SQL extractor file, then make golden data set, then golden data set first PY file. Now I will go here, model evaluator.py file, and here I have put all these 5 models. But as you know, I want to work on this also, this GLM 5.2. So I will go here. All these names are standard names which are present in the open routers models. Okay. Uh, okay. So I will just copy this, Control C, paste, go here, GLM-5.2. Okay, only one is there. GLM 5.2. So you can see over here GPT 5.6 Terra. This is the name of the model, and OpenAI GPT 5.6 Terra Pro. This name comes from where? You can see here OpenAI slash GPT 5.6 dash Terra Pro. OpenAI slash GPT 5.6 hyphen Terra Pro. Okay. So like this, I will check here GLM 5.2. Okay. GLM dash 5.2. Okay, GLM 5.2 I will select and I will copy this. I will paste it over here and here I will copy this, paste it over here. I will save this. Okay. So like this, you can see MinMax M3, MinMax M3 slash MinMax M3. So this is also selected. Okay. We have selected this many models. I will save this. Okay. Now here you can see our evaluator.py file is present and main.py file is present. These two files are pending right now. So in the evaluator .py file, I will just make this as a word wrap. So here you can see we are evaluating means with the help of our golden data set. Uh, First of all, we will run the golden data set. Then our SQL queries are generated. These SQL queries will hit to the SQL database and we get the output. The same questions we will pass to the LLM model and the LLM will give the SQL queries. This SQL query will hit to the SQL database and we will side by side check whether they are working or not working. Okay. So what is the exact logic we have provided in this evaluator.py file is that if see we have golden data set, right? In that golden data set, natural language English questions given by the user and the SQL queries generated by the analyst are present, right? So we will we are getting the SQL queries generated by the LLM models also, right? So now we have two SQL queries. We will run both the SQL queries on the SQL database and we will get certain output. What outputs? Either we will get a number or we will get a table. Okay. So if the number we are getting, then the number may be in the form of like 2.99993 or and if the LLM gives us answer like 2.9, then both are same. So how they become same? That logic we have provided in the evaluator.py file. Also another logic is like if they are giving us tables, then the number of rows should be same. If the rows are same, then also the generated output is same. So this is how we are comparing like the output generated by the SQL queries by the LLM model are equal to the output generated by the our golden data set means that SQL queries are same or not. If they are same, then the score will be 1, or if they are failed, then the score will be 0. So this is the logic we have given here. You can see. So rows as set, rows as tuples, so that you will see the integers like right. And this is a compare data frame. So this is golden data set and this is generated data set. So this is the entire evaluate one. Then you are comparing SQL queries with golden data set as well as generated LLM output data set. Okay, and you are getting the final output. So this is how you are evaluating, you are comparing the SQL queries. Okay. So this evaluator.py file is used in main.py file here. You can see database path, schema path, result, golden path is a golden dataset.csv file. Okay, so make LLM. A lot of questions are functions are there. Generate SQL query is there. Clean SQL query is there. Run SQL query, then close SQL query, run evaluation. You can see SQL is closed right now, and this is used to start the Python file. Means once you click on this play button, because of this line, the .py file will run. Okay, now I will run this Python file. First of all, I will clean this. This is very important. And before that, I want to show you the cost. Okay, what is the cost actually? Open router, yes. In the open router, where is the cost? Models. Yes, here. One second. So here you can see in the credit section $4.08. I will write it down here. $4.08. Okay, so this is the cost right now. Means these are the dollars present in my account right now. Now I will run this query. Okay, and you will see all the models are running. This will take some time, but it's fine. One second. You can see here for every model we are running this code. Okay, so here if you see for name and slug in models, I will just press Control and click on models. You can see we are getting redirected to model underscore open router underscore slug.py file where all these models are there. Now I will again go to main.py file and simply I will run this code. You can see the code is running right now. We are getting error. What error? Golden dataset.csv file is not present. So, okay, golden dataset.csv file not present. Okay, dataset. Okay, now I will again run this code. I will first clean this. Main.py file is selected. I will run this code. So, okay, now it is running GPT-5.6 Terra and it is taking a bit time. You can see 1921 is the time, 22 August 2026, 1921, Saturday time. So first query is okay, means they are matching like first SQL query, the SQL query generated by the LLM and the SQL query which is present inside the golden data set. They are generating the same responses, they are generating the same tables, or they are generating the same numbers. That's why it is matching. Otherwise, for the second query, it is not matching. So that is a simple thing. Uh, this is our golden data set, and these are the SQL queries actually. So this is second number query that is not matching. Okay, this is hard, this is brutal. So and this is you can see the latency as well. Means sometimes it is giving fast response, sometimes it is giving slower response. So 11th query is I think very hard. 11th query, you can see this big SQL query is there. Okay, it is mismatch. 1, 2, 3, 3 are mismatch right now. 12th is match. So 20 SQL queries we are matching with the 6 LLM models. And after that we will get which model is better. If the cost is same, if the accuracy is same, if the accuracy is same and the cost is very much differing from each other, then we will go with the model which is cheaper in cost. And you can increase the number of questions as well. Right now I have used 20 questions. You can use 200 or 2000 SQL queries, golden data set, so that you will get more precise output, more precise, means accurate your evaluation, and you will save a lot of cost also. So 15, 1921 was the time we start. Now it is 1923. I will have a short clock timer. Let's say I have timer or not. Clock. Okay, get started. This is the timer. Okay. Stopwatch. Okay. 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 For Kimi 3, I have started timing. For GPT Terra, you can see 3 minutes required. 1921 was the time. Right now, 1924 is the time is going. So 3 minutes required for GPT 5.6 Terra. Kimi 3 is far slower. I will pause the recording, and this is running actually, so that you don't have to wait. So 12 queries are running right now. You see in the leaderboard, Kimi 3, Kimi K3 means on also YouTube channel, YouTube videos. If you scroll, you will see a lot of virality, like Kimi 3 is powerful, Kimi 3 is powerful. It is beating Fable 5. But if you actually test it in your LLM evaluator.py file, then you will see a lot of errors, like leaderboard is saying something and it is not giving answer. So it is always better to evaluate all these models. You should not trust these models just by looking at their leaderboards. You can see so many mistakes are there. GPT 5.6 Terra gives us 80% accuracy, while Kimi K3, I don't think it is more than 50%. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is performing poor, also taking much time. Yes, so 50% accuracy is there for Kimi K3. Okay, so I will just, okay. And for Grok 4.5, what is the time required? We will see. It is faster, you can see. For Kimi K3, I think 3 point something minutes. It is slower actually, slower than GPT 5.6 Terra. Grok 4.5 is faster than GPT 5.6 Terra, and of course a lot more faster than Kimi K3. You can see within 2 to 3 seconds every SQL query it is running, and the SQL query is matching with the golden dataset. This is our third model, Grok 4.5. Accuracy is also good, and timing is also, means latency is also very low, which is very good. It is performing well on hard SQL queries, hard SQL questions, hard user questions, as well as brutal questions. Okay, we'll see. You can see very high accuracy Grok 4.5 is giving us. Only two SQL queries are mismatched. This SQL error means I think they are not able to generate the SQL query. SQL mismatch 1, 2, 3, 3 is here. Okay, 3 divided by 20. more, I think 85% will be the accuracy for Grok 4.5. You will see what is the result. 85%, yes. 17 is the score. Uh, Now Claude Sonnet 5. And what is the time? I didn't see the time. Okay. But it was faster. Claude Sonnet 5. 1, 2, 3, 4, 5, 6. 85% accuracy. So this exercise will help us a lot because previously it was like, okay, use the highest accurate model, Hubble, Mythos, Opus 4.8. And after that, after completing the entire project, we see like, okay, the cost is very high. We cannot proceed. Customers are not buying our application. But if we go in this direction, if we follow this approach, then we will see, okay, we can reduce the AI cost a lot, and we can give the same accuracy or even better accuracy. You can see 1, 2, 3, 4, 5, 6. 65% accuracy is for Claude Sonnet 5. Okay, 1.18 minutes, 1 minute 18 second. Now for MinMax M3 model, we will see. First is good, second is good, fifth is also good, fourth is wrong. So one SQL query is not matching. And see, if you run this code on your laptop also, you will see some differences. Like right now it is 65. In your case, it might be 55 or 75 because we have taken only small data set. Only 20 questions are there. More the number of questions in the golden data set, more will be, you can say, trust will be the accuracy. Trustworthy will be the accuracy. Okay. So the timing is also latency is also very low. You can see only 10 questions. 10th question is working. So 10 questions and 1.3 minutes. 10th question, whether it is matching or okay. SQL error. Okay, it's fine. SQL error, not able to generate the SQL query. These are Chinese models, MinMax and so on. So this is how you can see. I will pause the video. 19th question is there. Okay, 80% is the accuracy for MinMax M3, which is very good. Okay, 3 minutes was the time taken. Now JLM 5.2. Uh, I have a lot of hopes from this JLM 5.2 model. I like that so much and I want to use that. But as it is open source, so I didn't use it much. But and there are a lot of viral videos like JLM 5.2 is very 10 times cheaper than Fable model. It is beating Fable model and giving good accuracy, very cheap and like that. But let's see how much accurate it is. Right now, two questions are deleted, means 90% accuracy. Okay, 85% accuracy. Yes, we will see. Oh, 80% accuracy. So this is how you can calculate the accuracy. You should not trust the leaderboards and the marketings, their marketings. Right now, four questions means 80% is the accuracy. Well, see, speed is also good. Wow, the speed is amazing. Oh, 70% accuracy. Let's see last question. 70% will be the accuracy. Yeah, I will pause it. 1.5 minutes. Last question was error, 65% accuracy. Okay, so that's great. This is very very important. I will just copy this. Okay, I will copy this and I will go here. I will paste this. Okay. So here you can see side by side GPT 5.6 Terra giving us 80% accuracy, GPT 5.6, but the cost is 4.47 lakh rupees per month. Kimi K3 giving us 50% accuracy and the cost is 4.83 lakh per month. So it is gone. I will just draw lines like, okay. So I will not select this model. Okay. Then also I will not select GPT 5.6 Terra because of 80% accuracy. Sorry, because of the cost, 80% accuracy. Now Grok 4.5, which is giving us 85% accuracy. Grok 4.5, where it is okay, 2.5 lakh rupees a month, which is less than 3 lakh. Then comes our Claude Sonnet 5, 65% accuracy. Claude Sonnet 5, 2.84 lakh rupees, but accuracy is very low. So I will not use Claude 4.5. Then MinMax M3, 80% accuracy. MinMax M3, 42,000 rupees only. Okay. So now JLM 5.2, 65% accuracy. So accuracy is very low. So I will not use JLM 5.2. And definitely I will not use Fable because it is like 13 lakh rupees. So Grok and MinMax, as you can see that cost is only 42,000 rupees, which is nearly 26, which is nearly 30 times lower than Fable, and how much times? Nearly 5 times lower than this Grok model. Okay. So my final decision will go to this MinMax model. So this is the most important decision we have made so far. Mm, 1 second, add more colors. Okay, so MinMax I will use. So this is how I will decide which LLM model should I prefer. Whether I should prefer Fable or MinMax or any kind of model. Just put $5. I will also show you the cost. See, here I have write down 4.08. 4.08, right? I will also show you the cost 4.08. Now I will reload it. We have run 6 LLM models. I will show you the cost of running 6 LLM models with 20 queries only. I will reload it. You can see 4.08 minus 3 point, how much? 4.08 minus 3, 3.41 multiplied by 95.7 is the dollar rate is equals to 64 rupees 119 paisa. 64 rupees we required for one test. Okay, 64 rupees we required for one test. I have spent 571 rupees. So two tests I have done is nearly 125 rupees gone. This $3.41 are pending right now. 95.7, 326 means nearly 5 times I can do testing again as well. So these are the investment you have to do if you want to learn something new. Okay. So this is how I will decide which model should I use. $42,000, sorry, 42,000 rupees. If my peer companies are launching their product using this Fable model, and if I am launching the same application using MinMax model, then I will definitely win the game. Okay. So that's it. Means I have used my pen and pad to explain you everything. Um, and this is very important. Means it is not like a RAG, advanced RAG, and everything. But choosing the right model is also very much important. This is cutting edge technology, LLM evaluation. Okay, so you have to decide which model you have to use before building any kind of AI application, before launching any kind of AI application, so that you will stand confidently in the market and you can win the prize war in the product market. So that's it for today's video. If you really like this video, if you like my efforts, all the source code I will put in my GitHub repository. You can watch it. You can clone my GitHub repository as well, and you can practice it on your own. So if you like my YouTube channel, then please do like, share, and subscribe to my YouTube channel in this video. We will meet in the next video soon. Until then, thank you very much. Bye bye.